Well, as we start out here in Chapter 2, what I want to do is kind of go back and just recap what we did in Chapter 1, specifically that 1-6, 1-7, 1-8, and 1-9. Okay? Well, in 1-6, we just all talked about the linear equation, how we're going to solve a linear equation. What's our goal? Is how to figure out what that x variable represents, or that y variable, whichever variable was in the equation. Okay? And then further into Chapter 1, then we focused on how about, let's not just do just linear equations. Let's look at equations that have square roots. Let's look at equations that are quadratic, meaning they have the x squared term in there. Let's look at equations that have variables in the denominator, and let's see all about that. Let's see how we can solve them. So now that we've spent a whole entire chapter on solving equations, we're now going to move into Chapter 2, which is all about how to graph these equations, how to see these solutions. That's our goal, is we want to be able to see a solution. If you're just solving something quick and simple like 2x minus 1 is equal to 3, or in other words, x equals 2, if I asked you to graph that solution, it's going to be something basic. It's just a number line. We're going to go number 2 on it, draw a dot. Nothing too fancy. So what we're doing here really in Chapter 2 is we're going to start looking into the two dimensions. Two dimension being now our equations are going to have an x variable and a y variable, which makes sense because all of our history of graphing has always been an x-axis and a y-axis, right? So other than word problems, our typical variables, and from here in Chapter 2 is going to be an x variable and a y variable. And what that's going to do is now we're going to finally take it into equation of like y equals 2x plus 1. And when I want to go and graph it, I get both axes. Now I finally got two dimension. And we've got something we can definitely look at that's a little more thrilling than just a dot on a number line. Okay? So starting out here in Chapter 2. The first point we want to make is just all about graphing a line. In order to graph a line, what you need to know for sure is the slope, so how fast that line's changing, and then 1 point in order to graph it. Maybe 2 points depending on. Okay? How to find the slope, how to find this rate of change. Well, we have so many ways that y'all have probably learned it in the past. We can get that slope by, if we're looking at the graph itself, we can just count a rise over run, how far up it goes to how far right it goes. Okay, and what I have written right here, the letter M stands for slope. And one semester I asked one of my students, I was like, hey, does anybody happen to know why M? Of any letter in the alphabet, why do we choose M to be for slope? Well, then she actually went on the internet and came back with the information. I was kind of surprised by it, but it really has to do with the guy that found slope, quote unquote, found it, was actually a Frenchman. And the French word for slope starts with an M, so that's why we have M for slope. But anyways, looking at this basic definition, you know how we say rise over run, so how far up, and up is the y-axis. So this, when you have a triangle, it's read as the change, the difference, or the delta y. So it's the change in your y values, which is the up, the rise, over the change in x's, which is the run. It's going to the left and to the right. Okay, so if you look at a graph, you can easily just go, okay, how far up, how far down, left and right to get to another point. Now, if you have 2 points, then we can either graph the 2 points and then count rise over run, or we can just use a formula that if you have 2 points, sometimes in your history of math, you've learned this whole thing that, M is equal to y2 minus y1 over x2 minus x1. Well, I'm here to kind of crack a little bubble for you guys. It really doesn't matter if it was y2 minus y1 or y1 minus y2. It's just if you choose to subtract the y values going from first to second, then make sure you do the same thing with the x's from first to second. Or if you want to go from second to first in the y's, then go from second to first in the x's. It really doesn't matter. The key is that you're taking the difference. You're subtracting the y values on top, and you're subtracting the x values on the bottom. And that has to be because if you think rise over run, the axis that rises is the y-axis, so the y's have to be on top. The axis that runs is the x-axis, so the x's have to be in the bottom. Okay? So if we're looking at the graph, count rise over run. If we're given 2 points, you can just use the formula where you subtract the y's over the difference in the x's. And then for third one is if you have the equation, how we're going to find the slope if we're given the equation. Well, we all know about slope-intercept form. Its slope-intercept form is just y equals mx plus b, meaning if it's solved for y, then you're in slope-intercept form. And notice it's not 2y equals or negative y equals, it's specifically y equals. And when it's in that form, the slope is always the number that's attached to your x variable. Plain and simple as that. The other number in the very, very back is going to be a constant. It's not going to have a variable with it, and that's going to be your y-intercept. So if there's not a number in the back, then it's 0, so your y-intercept is 0. Okay, just some thoughts to keep in mind, but let's go over to example number 1. Here in example 1, we just want to find the slope for a line that goes through these 2 points. So in this case, what I could do is I could either graph the 2 points and then count rise over run, or I can use that formula. The formula for slope says it's the difference in the y's, and I'm just going to go left to right. So -2 minus a -4 over the difference in the x's. So I need to go left to right with the x's as well. So -2 minus 4. All right, or -2 plus 4 over -2 minus 4 will give me a slope of, see, -2 plus 4 is 2. -2 minus 4 is a -6. So my overall answer is the -1/3. Okay, well, let's graph this and see if we kind of get the exact same thing going on. Let's see. 1, 2, 3, 4. All right, so -2, -2 right there. 4, -4 right there. Okay, let's see if we can, obviously we would connect the dots. I'm going to try my hardest to do the best that I can here. It doesn't always come out pretty, but okay. So our slope says a -1/3. Well, what do we do with that negative? Is it both numbers, or is it just one of the number? Just remember that if you write it as negative out front, that's the exact same thing as -1/3, which is the exact same thing as 1 over -3. So if you ever have a negative sign out front, then you have a choice. You can either attach it to the top or the bottom, but never to both. Okay, I'm going to go with probably the second one. I'm going to start here with the dot on the left, and it says in order to get to my next point that I should go down 1 because it's -1, and then right 3 because the 3 is positive. So I'm going to go down 1 and right 3. So 1, 2, 3. Gives me a dot right there, and it's on that line. Okay, my goal is to get to the other dots. So let's try this again. I'm going to go down 1, right 3. So 1, 2, 3, right there on that line. And there we go. So it looks like they both check out. Our slope for sure is a -1/3. And the key with slopes and lines is the fact of no matter what I choose to do, if I wanted to go with, let's say, this second one right here, let's start with this right dot. If I start here, then my 1's positive, so I'm going to go up 1 and left 3. So 1, 2, 3. I get right back there. So the key with lines is the fact that no matter what I do, I'm always going to have, no matter what 2 points I pick along that line, I always have the same slope. The definition of a line is it has a constant slope. If it doesn't have a constant slope, then it's not a line. It's going to be a circle. There's going to be a curve, a parabola. Okay, so something that has constant slope is something that will have a line when graphed. Okay, all right, let's go on to example number 2. Given the equation -y plus 3 equals 4x, we want to find the following. Is the slope positive or negative? If x increases in value, does y increase or decrease? Okay, let's start out here at the very first one though real quick. I want to know all about the slope. They're asking me questions about the slope. Can I tell the slope right now? Well, it's like, ooh, is it just that number that's attached to x? Well, it is, but as long as we're in slope-intercept form, and we're not in slope-intercept form. So let's get in slope-intercept form. It says -y plus 3 is equal to 4x. Slope-intercept form tells me I've got to isolate my y. So -y is equal to 4x. Moving that over, so now it's -3. But I don't want -y equals, I want y equals. So let's divide off that coefficient. And so in slope-intercept form, our equation really is y is equal to a -4x plus 3. So here's really our equation. So the question says, is the slope positive or is the slope negative? Well, the slope is the number, just the number attached to the x term. So if I took away the x, whatever's left over, that's my slope. So m in this case is -4, or if you want to write it, you can say -4 over 1 or 4 over -1. Either way. Okay? Now it says, and if I want to think about it, if I want to just graph this real quick, let me go down to the 4th bullet just real quick. Okay? It says to graph this. And and our equation was, negative 4x plus 3. So if I wanted to graph that, remember, always your constant term, the number that's the only other term up there that doesn't have a variable with it, that's your y-intercept. Everything up there is a variable, the y, the x's, and then we have this plus 3. And if we want to graph our slope, remember we said, was negative 4, which is negative 4 over 1 or 4 over negative 1. Okay, I'm going to do probably this one so I can stay on my graph a little easier. So that says my rise is negative, so I'm going to go down 4. 1, 2, 3, 4. My run's positive, so it's going just like that. Okay, seeing a picture is going to help me answer my next question. Because my question says, as x increases in value, so for x to increase in value, that means I need to go right on the graph. So as I'm going right across that graph, what happens to my y values? Does it go down or does it go up? So let's think about it. If I start here on this graph, let's say right up here at that y-intercept, and I'm going to go to the right on that graph, in order to touch it, to go back to the line, don't I have to go down? So it's saying that my y values decrease. The y's decrease. If the question says as x decreases in value, so if it said x decreases, that would mean as I go left on the graph. So if I go left, start on one dot, and I go to the left, then in that case, then my y values would increase because I would have to go up to touch the graph. Okay, so just some things, just ways to interpret, just looking at these things, and probably a new way that you haven't seen before or thought about, but that's okay. Just going to help us understand a little bit more. Okay, and then to answer this last question referring to the graph, it says if my y values decrease by 2 units, so let's start at this first dot right here. And if I go down by 2 units, so just down by 2, then in order to hit the graph, what's the corresponding change in x? So in order to hit my graph, then the change in x is we need to increase the x's by, to get over, was just 1 unit. And if we want to check again, if I went down 2 units in the y, it'd be over 1 to get back to the graph. Okay? Let's go on to the next topic.